Now, to show some examples of the global observations of what's happening in the last few decades, we see that the amount of sea ice in the Arctic depends, it fluctuates from year to year, but it's decreasing quite substantially and has decreased about 30%. And within a few decades, we will probably have no sea ice left in the Arctic at the end of the melt season. In the last year and a few years ago, we've twice had this Northwest Passage open as the amount of sea ice has decreased. The melting on Greenland we can now observe from satellites, and that fluctuates from year to year, but overall the area is tending to increase. And that meltwater on Greenland will go to a low spot on the ice sheet, burrow a hole in the ice sheet, and lubricate the base of the ice sheet, speeding up the discharge of these giant icebergs to the ocean. And that's one of the processes that's contributing to the mass loss from the ice sheets. The mass of the Greenland ice sheet increases during the winter as the snow piles up, and then during the melting season it loses mass. But overall it's losing mass at a rate that seems to have increased over the period since the gravity satellite began to measure the mass of Greenland very accurately. And similarly, Antarctica seems to be losing mass at not quite as fast a rate, but again, the rate seems to be increasing over the period of data. Another expected effect of global warming is an expansion of the Hadley circulation, the rising motion in the tropics and the subsidence which causes the subtropics to be dry. That circulation cell is expected to expand. And empirically, averaged over all longitudes, it has expanded by about 4 degrees of latitude. And I think that's one of the reasons why Lake Mead and Lake Powell are only half full. That expansion of the subtropics is affecting the Mediterranean region, the southern United States, and in the southern hemisphere, Australia and parts of Africa. Of course, the weather patterns fluctuate from year to year, and this is a La Nina year, which may contribute to the droughts in Texas. But this drying in southern United States is, I think, at least partly related to this trend due to global warming. And the climate models, this is an example which does show that not only Mexico and the Mediterranean region, but the Midwest U.S. is likely to experience more extreme droughts in the future. But of course, and that's the reason why both in the southern United States and western United States, the fires are covering more area and burning hotter. There are other things that contribute to that, but the same is true in the Mediterranean region, in Greece and in Australia. At the same time, of course, as the atmosphere becomes warmer, it holds more water vapor. So at the times when you do get rainfall, you get more extreme events, and therefore you get more extreme floods. So both ends of the hydrologic cycle get strengthened by global warming. And the glaciers all around the world are melting back. In the Rocky Mountains, the Andes Mountains, the Alps, the Himalayas. And it has practical importance because these, during the dry season, more than half the water in rivers like the Ganges and the Brahmaputra is from melting ice. So once the glaciers are gone, the dry seasons are going to be much drier. The rivers are going to tend to run dry. Another effect is on coral reefs, where both the warming of the ocean surface causes the corals to expel symbiotic algae, and which they require to live. And the acidification, as the ocean takes up CO2, it becomes more acid. And those animals that have carbonate shells or carbonate skeletons are weakened and eventually can't survive as the ocean becomes too acid. So for several different reasons, we would argue that to keep a planet that looks like the one that's existed the last 10,000 years, we should try to keep CO2 no higher than 350 parts per million. Perhaps the optimum target is actually somewhat lower than that, but in any case, if we want to avoid large damaging effects, we need to keep CO2 less than 350 ppm. And the best way to evaluate this is to just look at the planet's energy balance. If it's out of balance by half a watt per meter squared, then we would need to reduce CO2 by about 30 or 35 ppm. If it's out of balance by 3/4 of a watt, we would actually need to take it back to something like 340 ppm if we want to restore energy balance, which is what you need to do if you want to stabilize the climate. But what that means is that we can't burn all the fossil fuels, because the CO2 that we put in the air by burning fossil fuels stays in the surface reservoirs. It distributes itself among the ocean, the atmosphere, and the biosphere and the soil, but it stays in these surface reservoirs for millennia before it's eventually deposited on the ocean floor as carbonates. So what it tells us is that if we just burn the remaining oil and gas, we could get CO2 to peak at something less than about 425 ppm if we would phase out the coal over the next few decades, and if we would leave the unconventional fossil fuels in the ground. Then CO2 would peak and begin to slowly decline. And if we had aggressive programs for reforestation and improved agriculture to store more carbon in the soil, we could get back to 350 ppm by the end of the century. But the requirement is that we'd have to phase out coal emissions quickly and not develop the unconventional fossil fuels. But what's actually happening? We're talking about building pipelines to carry tar sands oil to Texas. And we're continuing to build coal-fired power plants all around the world. And we compare, you know, up until the Kyoto Protocol, CO2 was increasing like 1.5% per year, or the CO2 emissions. Since then, they've been increasing about 3% per year. So, despite the knowledge of the impact on climate, the emissions are actually increasing faster. So there's this huge gap between the rhetoric and the reality. The president says we have a planet in peril, and yet the policies are basically business as usual. The fundamental problem is that as long as fossil fuels are the cheapest energy, then we're going to keep using them. The reason that they're cheapest is because they get some subsidies, but that's not the main problem. The main problem is they don't pay their costs to society. Just the effect of fossil fuels on human health, where air and water pollution is killing about 1 million people a year, maybe 50,000 in the United States. Those health costs are borne by the public, not by the fossil fuel industry. And the bigger effect in the long run is the climate change effects, which again, there's no charge to the fossil fuel industry for that. The cost will be borne by the public. So, there's another, so the fundamental thing is the only way we can solve the problem is to make the fossil fuels pay for their cost to society. That means you've got to add a price to the carbon emissions. But the other fundamental thing, which is almost as certain as the fact that we keep burning them as long as they're cheapest. And that's the fact the public is never going to allow you to put a large tax on carbon emissions if the money is going to Congress, who then gives it to their favorite lobbyist. So I argue that what we should do is add a fee to carbon across the board, oil, gas, coal, at the source, at the local domestic mine or the port of entry. It has to rise gradually over time. If it started at $15 a ton and goes up $10 a ton, then after 10 years, it's $115 a ton, which is equal to $1 a gallon of gasoline. But that tax would generate $600 billion a year with the present use of fossil fuels, which if you distribute that to the public, an equal share to each legal adult resident and half a share to each child up to 2 per family, that's between $2,000 and $3,000 per person per year, or $6,000 to $9,000 per family with 2 children or less. That would allow the people to begin to make the changes that they need to in order to reduce their carbon footprint. And in fact, 60% of the people would get more in the dividend than they pay in increased energy costs. But with the knowledge that that fee is going to continue to rise, they will begin to make changes, or they're going to end up on the short end of the stick. But that knowledge that the fee is going to go up would cause all kinds of innovations. If the business community knew that was really going to happen, we would have all kinds of changes, and we could move to a clean energy economy, which we're going to have to do anyway. Fossil fuels are finite, so we're going to have to find clean energies in the long run.